Okay, good afternoon, .NET Fringe. Are you happy with the conference in the meanwhile? And show of hands? I'm very happy, yeah. That's a good one. And what else is good is this talk is going to be a great talk. And I have a proof for you because it starts with code. But not that exciting code, okay? So we look at this piece of code that basically breaks down a header. You can think about HTTP header, all kinds of other message headers, something like that. The rule is that a header might have a name, colon, and then some value. So we use the split command. Hope it's big enough. If it's not, it's quite boring to begin with. It's just going to split it to two pieces, and you get back first part and the other part, which is pretty cool, right? But then you think, this is pretty repetitive, and I need to new up this guy every time. You might spot the bug here. It's missing the new. But let's write a util class and do this instead, which is generally a good idea. Is that a good idea? Show of hands? Not many hands either. Nobody's listening, or it's a bad idea. And if it's a bad idea, I might agree with you in a minute. So yeah, that's what happens. At some point, I say, well, util is like too general. Let's make it a string util, or better yet, header util. Now, it's a little bit more concise. It's going to be more cohesive, because this helper class is now going to be specific for header utils, and now it might be worth it, so I won't be sticking all kinds of unrelated utils in there. Now, is that a little bit better, show of hands? Yeah, is this better? Yeah, I like that you don't put your hands up, because it's not. And we'll see that in a moment, because what happens when you want to don't repeat yourself, right? We start with this. Triangle is the header util that I had. Now I'm using it in two places, and I have two header utils. Best idea in the world is to do that. So we have a new package, the util package, or maybe header package to be better at that. Now A and B just depend on that, and we reuse the code. And it's sort of great. But what happens when header line was no colon? So who here knows their BCL pretty good and knows what happens when you split something and the split is not there? Is this, or that? So if you think it's one, raise one hand. If you think it's two, raise two hands. If you think it's three, just don't do anything. So everybody thinks it's three, right? Or you're not listening. So yeah, there is a winner. That's what happens, right? So we have two places in the code. Each one of them handled it a little bit differently. A said, if header parts length equal 1, that's the way they want to handle this, then they'll do this case. Well, the developer who works on B, he likes this model more. So he's saying, if the second part is null, then do this, and then it just changes split header to return the new stuff. What happened to A? A broke down. So by reusing our code, what we actually did is create a dependency not on this, but a cyclic dependency between these two. So now A depends on B and B depend on A, because every time B is going to change util, it's going to maybe break A. Every time A is going to change util, it's going to be maybe breaking B. And this could become even more and more worse. And it could be somewhere hidden, so we have something here that depends on that, depends on that, depends on that, and you change it, and then everybody else might break. So you need to have a very good continuous deployment setup by which you test all of your possible consumers everywhere to make sure you didn't break anyone, which could be pretty tedious, not always the best thing to think about the whole time, right? So reuse always leads to increased dependency, always lead to increased coupling. It's not always the best idea. This is definitely too small. What it says here is Uncle Bob's principle of OOD. So next question I'm going to ask you guys is, who here have heard of solid principles? If you heard of solid principles, shout yes. Have you heard of solid principles? Yes. Yeah. How many principles are there? 5. No. So if you go to this page, if you just Google this, the Uncle Bob's principle of OOD, there are actually 11 principles there. The first 5 are the solid principles that we all know and love, especially the Liskov substitution principle that everybody knows exactly what it is. But there are other 6, and the other 6 talk about how you build your packages and how you manage dependencies between the packages. One of the things it talks about there, for example, is the stability of a package, which is defined by how many external packages are using this package versus how many external packages is this package using. And the definition is that if this is a package that is being used by many others, then by definition it's a stable package, not because it was well thought of, not because it's best designed, but because if you want to change it, you're going to hurt many people. You need to think about many people, and you're probably not going to change it as often, so it becomes stable. And then one of the principles talks about always take dependency on packages that are more stable than yours. And if you really go by that, you can somehow be able to reuse code and put things in one place, but in a manner that would not be as painful as you might think. Now, in most cases, the best idea there is to think about if I'm following DDD and if I'm following CQRS, if I'm following the real service orientation architecture, which we'll touch later on, by which we're making a good separation of concerns between logical pieces of our code. If I have a logical piece of our code that is doing something that is business critical for my application, I'm going to put it in one place and not put the code in other places. That would be a good time where I want to balance the increased dependency, the increase in the dependency graph or the complexity that I put there with the fact that I want one piece of code to own the logic for this business critical stuff. String helpers, probably not that important for us. We can just rewrite them and we can copy and paste them. It's probably going to be better. All right, so let's practice our yes, no's a little bit further because we might want to use them later. So .NET Fringe. Do you like .NET Fringe? Yes. All right, that's good. C#. Do you like C#? Yes. All right. Do you like meetings at work? Oh, yeah, sort of works. I think about something else. Do you like F#? Yes. You like Java? Yeah. Awesome. So yeah, it sort of works. All right. So now that we finished with the practice, we can talk a little bit about best practices. You can't see it here, but there's this blue line that tells you how far off are we. So we're making good progress, I think. So best practices. That's what a best practice is. You can trust me or you can read Wikipedia. That's what best practice is. And I think the most important word here is any, which relates to best. So if it's the best one, it has to be better than anything else, right? So let's talk about best practices. What do you think about that one? Are stored procedures best practice? That was enough. Yeah, that's you nailed it, sir. How about that? No, wait, not this one. How about waterfall? Is waterfall a best practice? Oh, that was better. So if it's usually no, then it's not best, but probably not worst. Is soap a good practice or a best practice? Unequivocal, no. Rest, oh, that's a tricky one. Is rest a best practice? Is it better than anything else in any circumstance? Glenn, what do you think? No. The common thing about all these is that at some point, they were best practice. When I went to, probably before I went to school, because I'm not that old, stored procedures were just thing. You can only do SQL if you do stored procedures. If you don't do stored procedures, then the RDBMS would not cache your curl plan, which is pretty bad. Waterfall was the thing in school. You go to school, in the CS school, and they tell you that's the way to manage projects. That's how we did it for so long. That's how we flew people to the moon. That's how you get paid every month. That's how everything works. And it worked, and maybe not in the best way, but that was a best practice at some time. SOAP was at least marketed as best practice. Definitely REST has been marketed as REST practice. These things at some point have been best practices. They're not anymore. Look at any pieces of your code from many years ago. It probably has a BLL project. Do you still have BLL projects? Yes or no? No, yeah, it used to be the best practice. You have DAL, you have BLL, you have all these guys. We don't do this anymore so often. Definitely not always. Definitely not above anything else. Best practices are a myth. However, bad practices, how about that? Who knows what this thing does? If you know, say yes. Do you know what this thing is doing? Yeah, so many people know. Is this a good idea to put this in our code? Not necessarily, right? So if you don't know what this thing is, basically this is a way to copy a string, because it would stop when you get to the null character, the null byte. Probably a for loop would be more readable. If your team are all like C hackers, it's going to be very easy. But by the way, that's not F#, just so you know, right? So if your team are all C hackers and you're comfortable with that, awesome, no problem, put it there. If not, not. Generally, that wouldn't be a great idea to put it there unless you have a good reason, but then it would be an okay idea. So it's not a terrible practice, but it's quite bad most of the time. What about giving interns a limited access to your database, right? How about that? Is that a good idea, bad idea? It's not a great idea, right? Yeah, we've seen what happens this last week with that. How about something completely different? Using your phone while biking. All the bikers and cyclists here. Is it a good idea to use your phone while biking? You don't know my life. Yeah. So yeah, all this is not necessarily great, but then there are worse practices. For example, remember the guy who had database access? I mean, yeah, let's give everybody access. We can always roll back if something bad happened. Guess what? They didn't have backups and they didn't practice the rollbacks. So if you don't proactively test your disaster recovery scenarios, you probably won't be able to recover from disasters. That would be terrible. That won't be good. So that is definitely a worse practice. Never not proactively practice your disaster recovery if you have one, and have one. How about shut your eyes while biking? That's definitely a worse process. There's nothing good about that. Reversible passwords. Is anybody storing encrypted passwords? This is just like storing them in clear text. This is not a good idea. Passwords should be hashed and salted and caramelized and I don't know, this stuff. You probably also don't want to do this yourself. There are like libraries like bcrypt and stuff like that should do this for you. But yeah, these are worse. If you do that, stop. So yeah, practices. We have good ones, we have bad ones. By the way, good practice is to charge your clicker before the talk. Charge your clicker, yeah, all right. So yeah, we have good ones, we have bad ones. We definitely have worst. We do not have best practices. Important to remember. How about TDD? Is that a best practice? Yes. Well, we'll see about that. So what TDD is, many people will, there are all kinds of ideas about what it is. I'll think about like the widest term, which is the red-green refactor thing, which you start by writing a broken test, then you make it green by doing the simplest implementation possible, and then you refactor it. That's how it works, generally. TDD is not a design tool. Again, I did not say that. The guy who said that is our friend from a previous slide, Bob Martin, who is one of the biggest TDD's priests in the world. And he says, TDD is a discipline. It doesn't create or creates good design or bad design, right? If you think you'd use TDD, and by the virtue of using TDD in some form or way, you have good design, that's wrong. Now, this thing started a sort of a war. DHH, if you happen to know this guy, David Henemayer Hansen, he wrote an article not long ago called Test-Induced Design Damage, and he talks about how certain usages of TDD that he saw ended up with very bad designs of code that is difficult to work with and difficult to change and difficult to test and difficult to do a lot of things, and the overall design was too complicated to his opinion at least. And then Uncle Bob Martin wrote a different one, a response, and the response said the quote that I brought from before, which basically says bad designers induce design damage, not TDD. And if you ask me, what I would say is that TDD applied badly would often lead to design damage. So I wouldn't say that TDD is a worse practice at all. I wouldn't say it's a bad practice. It's definitely not a best practice. So there are cases where TDD actually breaks down completely, that you just cannot TDD your things. There are places where it's great. For example, when you have a bug, the best way to fix the bug is to start with a test that proves the bug is actually happening, fix the bug, and then you can refactor forward. But that's a very good time. When is it bad? When you test your subunits. So what's a unit? Is unit a function that does header dot break down to 2 pieces of header? Probably not. If you just write too many tests for this thing with mocks and stuff, you probably are doing too much. If you have an integration class that all it does is getting some state, pushing over to some other things, and then bringing it back, and all you do is you write mocks to just say, hey, assert that if I was given 5, I told some other guys 5. Probably this test, once you refactor, will break. So it's not going to be a red-green refactor. It's going to be a red-green refactor, red again, which shouldn't happen. It should stay green. If you isolate stable code, if you remember what stable code is, it's code that everybody else is using. It's unlikely to change anyway. It runs fast, and all this like if you isolate string.split by introducing iString splitter to your code, and many people do such things, it's a bad idea. So if you test things that are too small, probably not a good idea to DDD them. How about that? You know this? How do you draw an owl, right? So you start with something simple, you refactor, then you get this owl. So one of the first time I was introduced formally to TDD, even though I knew about this because I've been reading, I went to a place that had a TDD colons, and they had this. That's TDD prime generator, and we start with 1, right? That's the beginning of the owl, and we implement it that way, and then we implement it that way, and then we drew the fucking owl. Now, there's no stage by which this to that has been driven by TDD. This has been driven by reading Wikipedia, right? How do you solve this thing? You just read Wikipedia and then know the algorithm, or you just know the algorithm. Yeah, some F# tier tribute, so we'll be happy. So we pray to deliver software. We write quality code to do that. We might write automated tests. We might do TLA plus to validate that the test work. We might do formal validations and not necessarily tests. But if we do, we want high coverage probably of our tests. And if we want high coverage, we could choose to use TDD or test first to get that high coverage. But that's not a best practice that always works for everything and will guarantee a good design. How are we doing on blue line? Not bad. All right. Have you heard about that? This is part of a little site that I happen to work on. Where is this guy? Okay, there it is. All right, so this is a site called Amazon. Quick note, I work for Amazon. I worked before for Microsoft. Nothing of what I'm saying here is like internal to Amazon or Microsoft. It doesn't represent what they think. It only represents what I think. Everything that I'm going to say you can find online in blogs and places that have been out for many years. No secrets or anything like that. So yeah, you can go. No reason for you to stay. Yeah, this thing is a product page. So you have all kinds of, you have images, and this one only has one, and large image, small image. You have price, and maybe some other prices by other sellers. You have similar stuff, and other similarity, and these guys and those guys. You have descriptions and stuff, all kinds of these things. And the question is how many? How many of these things are there? And what are those things? So let's start with clicking outside of the iframe, and then continue with asking a question, how many teams? How many teams are involved with that thing? A whole lot. Almost anything you see there is a team. There's a team that does title, and there's a team that does parts of the description and other parts of the description. Like tons of teams are in charge of all this, and that's just apparel. You have cameras, you have videos, you have music. Everything is a separate set of teams. So the number of teams involved with that is pretty high. Now, if you know anything about SOA, right, or microservices, is that teams that build business value have services. How many services? A whole lot of services are involved with this thing. How many network calls involved in rendering this page? I'm not talking about this is in CQRS world, and this is very CQRS. This is just the query part. This is the part where we read mostly data that has already been denormalized. Tons of network calls happening there. How many resources spent deserializing? A whole fucking lot. So you serialize and deserialize the stuff across all these network calls. You pay in time, you pay in CPU, you pay in complexity, which is insane. All right, so let's go back in time. Again, all what I'm going to say is all like in Wikipedia and blogs and stuff, and Steve Yegi and all these guys. Back in the time, there was a thing called Abydos, which basically is it's an app that you just write and compile, and you have a big binary, you shove it in, and there it is. It works, and everything is there. And at some point in early 2000, this thing came out. You have to expose their data and functionality through a service interface. The only communication is via the service interface, via the network. Deployments have to be decoupled, the operational model is decoupled. Basically, everything that you hear today on what microservices are has been started to be done here, and by mid-2000, the old stuff was completely phased out, and everything is like that. And it's called Garupa, which is now how the things evolved into. It does have some problems, right? So latency has been increased, as I said, because you need to like go through all this crap. Access exceptions, so because there's latency, some things cannot have high latency, you just get an exception. I'm going to read this guy's data. Cost is crazy. Service discovery is almost unbearable. Consistency is a huge problem that I won't even talk about in this. There's no time. There's like 30 minutes separate for that. Oops. Yeah, imagine the, the everything is fine GIF. Couldn't find it, didn't have time, but yeah, everything is fine. My service works, and everything else is on fire, but my service works. But I just DOS someone else, and the whole thing is just not working anymore. Happens all the time. How do you debug an issue? When something is wrong, how do you know where it is? When there is a pager, something got wrong, happened, who do you page? Who can fix it? It's very difficult to figure this out. And Amazon figured most of these things out, but it's very costly and very complex. This is a slide that I found somewhere on the internet, a slide on microservices, the Death Star diagram. Notice this is Twitter for 2013. This is Amazon from 2008. So it's like a few years into this Garupa thing. Now we're 9 years later. I can guarantee you that this is about that size now. It's quite terrible, right? So what happens is that you have something like this, and then you break it down to microservices, but you did not make your dependency graph better. The only thing you did is to increase latency. So you traded this big pile with like a bunch of small piles. It's not guaranteed to. Now, this is not what we did. We did a far better job. I'm just a year and a half there. Amazon did far better job, but still, by the fact of putting microservices in, you're not going to solve any problem. You need to solve your design architecture first. And then, once you solve your design architecture, why do this? Because if you did that, but you don't have all the dependencies, maybe you don't have to go out to have different services. So service boundaries are logical, and it's something that I've been trying to promote for many years now. When you have a service boundary between, I don't know, HR and something else, whatever, all these things, it's very important that you have, like HR, they control the HR data, and the only way to contact them is via service interfaces, but the word via the network are wrong. There's no reason to enforce that. I'm not saying it's worst practice to do this over in the network. Sometimes it's a good idea. But the key is decoupling. It doesn't have to be physical, though. Physical decoupling just brings the whole mess and stuff that you need. All these things that we hear about in the recent years are just built to overcome this, which is pretty terrible. Got some more stuff? Some more things that I wanted to cover, but I don't have time for them. Upfront design. Is upfront design a good thing or a bad thing? Say yes or no. Good thing? Yes, upfront design is awesome. People don't like it. Yeah, the big upfront design and stuff. I truly believe in like having a focal point to which you make your small course correction to the right place. Otherwise, all of the fixes that you're going to do are going to sum up to a vector of sum 0. Also, checking in libs into Git. Awesome idea. But don't have time for this. That's me. That's how you can find me. This talk and others are on this URL if you can see it. I'm Egozi everywhere. So to recap, no best practices. Avoid the bad ones. Practice the good ones. Be intentional about your designs and build great software. Right? I have 12 more seconds, so the last thing I want to say, if any of that interests you, high concurrency stuff, and millions of requests per second, language design, because we do a logical language, which is like the bastard child of, I would know, Lisp and Prolog and SQL or something like that. So we have language design, tools design, we have crazy small latency and high concurrency distributed systems. If you want to hear about any of that and want to work for us, you can find me. All right, thank you very much.